Hi guys, Ms. Carr here. So normally I record these while we are in class. However, when we learned this today, we were in breakout rooms and I can't record in a breakout room. So I am doing this after the fact for those of you that maybe missed class or need a quick refresher. All right, so our learning target today is 3.2.1B. It's B because we started learning our algebraic methods to solve systems of equations the last time we were together. We did substitution. Now we are learning another way. So our I can statement for the day is I can solve a system of equations using elimination. Up to this point, we have two methods to solve a system. Our first method that we did was graphing. Our second method that we learned was substitution. And now this third method that we're learning is elimination. Now graphing is pretty self-explanatory. You're graphing the lines to see what's going on. Substitution and elimination are both algebraic methods. So we are learning the second algebraic method, the third method altogether to solve a system of equations. All right, now before we get started, I want to kind of rewind all the way back to elementary school. And I want us to think about how we would have solved these two problems that you see on your screen without the use of a calculator. When we were taught it way back when, we were told that you need to go column by column. What I mean by that is that you start from the right and we would look and all the numbers that are in similar columns will either be added or subtracted. So for this first problem, 6 and 2, we would add together to get 8. Then in that second column, we'd have 2 plus 5 to give us 7. And in that last column, we would have 2 plus 3 to give us 5. So we went column by column, added each column. Now, this second problem is very similar, except instead of adding, we are subtracting. We are still going to go column by column, though. Make sure everything is lined up, and the numbers that are in the same column, those are either going to be added or subtracted. In this problem, subtracted. So 3 minus 1 gives us 2, 8 minus 2 gives us 6, and 9 minus 4 gives us 5. So that's a skill that we learned way back when. We might be a little rusty, but we did learn it. And it's very, very similar to what we're going to do today. But today, instead of dealing with these numbers, we are going to be dealing with equations. We're still going to be looking at our columns. We're still going to be adding. We're still going to be subtracting, right? So before we get started, I crossed off this definition of elimination because we've kind of talked about it a bunch already. It is one of our 3 methods and the second algebraic method to solve the system. But I want to point out our steps here. So this first step, make sure all the equations are lined up. I will show you what I mean by that in our first example. Then, depending on the problem, you'll see what I mean again in a little bit. Depending on the problem, you're either going to add or subtract the variables. And it's really what makes sense in that problem. Then the idea is that we can then eliminate one of the variables with the common coefficient. Remember, a coefficient is just the number in front of a variable. And you're going to solve for the remaining variable. Now, if we think back to our system of equations, we know that we have to have 2 numbers as our answer, an x and a y. So even after we solve for one of our variables, we're still going to have to go back and solve for the other. And this last step is going to feel like substitution because it is. We're doing the same last step as you would in substitution. What has changed are these first 3 steps. All right, without further ado, let's get into our example here. So in this example, what I want to do first is I want to make sure that the variables are lined up. And I should have been a little bit more specific here because we're not just making sure variables are lined up, we're making sure the variables, the equal sign, the constants, everything is in the right place. So if I look here, all my x's are together, all my y's are together, my equal signs are together, and those constants are lined up. So that means that elimination is a go. That's a good indication that elimination is the process you are going to want to use. So for elimination then, what we're going to do in this problem, we are literally going to treat it like a big addition problem. So I'm going to put a plus sign and a line underneath. And just like we did in our warm-up, we are literally just going to add all of our columns up. So we're going to start from the right. In that first column, 5 plus 11 is going to give me 16. Then we add our equal signs stay in the same place. Now we're on to that next column. 9y plus 7y is going to give me 16y. And then 4x plus negative 4x. This is going to seem a little bit weird at first, but it's actually what we want. This gives us 0x. And so the whole point of elimination is that we want to eliminate a variable. And looking at what we've just done, I've done that. I've gotten rid of my x's. I have 0 x's. So I can actually really cross off our x's. And we're just left with 16y equals 16. Then this just becomes a one-step equation, which is easy peasy. We know it, we love it. All we have to do is divide by 16 on both sides to give us our answer of y equals 1. However, we are not done. If we think back to how a solution to a system of equations looks, you need to give me an answer in an ordered pair. So right now I have one of those values. I have my y value, so I can put it in the y's place. I still do not know that x value. I still have to figure that out. So what we're going to do is we're going to use this y value to help us find our x value. I can take this 1, and since it is equal to y, I can then go back to my original equations, and anywhere we see a y, we can put a 1 in its place. And now you can use either equation for this from what we were originally given. That is totally up to you, personal preference. You're going to get the same answer no matter what. I'm just going to use the bottom equation this time. So I have negative 4x plus 7y equals 11. And then I'm going to plug in 1 for y. So I'm going to rewrite this. Instead of y, I'm putting a 1. And then all we have to do from here on is just solve that multi-step equation. So I see those parentheses. That's my indication that we're going to multiply. Then we're left with negative 4x plus 7 equals 11. This brings us to a third wheel situation. So we can get rid of that third wheel on both sides. And I should have been drawing my line. Bad miscar. And I have negative 4x equals 4. Now my couple's all alone on that left side. However, we don't just want the couple all alone. We want the x alone. So I'm going to then divide by negative 4 on both sides to give me my final answer of x equals negative 1. So we now have a y, we have an x. We can take that x value and write it in my ordered pair solution. And voila, we have our solution to our system of equations. Yay! All right, so on this next frame, you're going to see another example. Here was another example that we did today in class. Here, we added up our values, and this time, instead of eliminating x, it eliminated y for us. So, because we had a negative 3y and a positive 3y in that y column. So when we added it, we were then left with that 0y that we could cross off, and all we had to do was solve that one-step equation of 8x equals 24 to give us our x value. Then finally, we can take that x value and plug it in to one of our original equations. And we chose to plug it into this top equation, but you could have plugged it into the bottom one. That's totally up to you. It's personal preference. You're going to get the same answer. And you can see in the second row here, that's where we plugged in the 3 for our x. And then all we had to do was solve to get our y value. Once we had our x and our y, we were then able to put them together in an ordered pair. All right, let's look at one more scenario. So what if adding them won't work? So let's look at this example. Here, let's imagine for a moment that I used that same method. I added these two together. When I add these, I'm going to end up with 29 equals negative 19y and 6x over here. That hasn't helped me at all. I haven't eliminated a variable. I've just given myself a third equation that I don't know what to do with. So adding is not going to be the route that we're going to take. Instead, for this problem, we can then subtract. Because if we subtract, 3 minus 3 is going to give me 0. Now, a word of warning. You have to subtract the entire equation. That means you're also subtracting negative 9 and you're also subtracting 15. So it's kind of like distributing that negative. Okay, so I'm going to subtract that. When I do, let's start from the right. We're going to do 14 minus 15 to give us negative 1. Keep our equal sign in the same place. And then negative 10 minus negative 9. I could really write that as negative 10 plus 9, which would give me negative 1y. And then finally, 3 minus 3 is just going to give me 0 x's. So yay, I've gotten rid of my x's. I now just have a one-step equation where all I have to do to solve is divide by negative 1 to give me my answer of y equals 1. All right, we are so close to being done. However, we still need to plug in that y to get our x value. Let's choose the top equation this time. So I have 3x minus 10y equals 14. And what I'm going to do, remember, I'm going to take that 1, and everywhere we see a y, I can now put 1 in its place. So I'm going to put 3x minus 10, parentheses 1, equals 14. And now we have our multi-step equation. So here we go. We're going to multiply when we see those parentheses, and then we get 3x minus 10 equals 14. Add 10 on both sides to get rid of that third wheel. And we get 3x equals 24. Finally, we're going to divide by 3 on both sides to give us our answer of x equals 8. So for our ordered pair, remember it goes x comma y. My final answer here would be 8 comma 1. Now let's imagine for a moment that I'm really nervous that I got this answer right. I'm taking a test. I'm not 100% sure. I'm just not feeling my best, and I want to make sure that I get this problem right because I want to do well on the test. Okay, what we can do is we can actually check our answers when we're done. To check your answer, you're going to use your solution and the original problems. And what we're going to do, I'm going to label my solution x and y. And we're going to plug in both of those variables to one of our equations. And again, this is an opportunity where you can choose. So let's choose the bottom one this time. Why not? I'm going to rewrite it here. And we are going to plug in our x and our y. So I'm going to have 3 instead of x, I'm putting 8. 9 instead of y, I'm putting 1. And then we simplify. So 3 times 8 gives us 24. Minus 9 times 1 gives me 9. because 24 and -9 are like terms, we can combine them, and we end up with 15 equals 15. As soon as you get the same answer on both sides, you know you did it correctly. If you get a silly answer like 8 equals 15, you know that doesn't make any sense, and you would have to go back and fix it. But because we got 15 on both sides, we know that we did solve the answers correctly. We had our right X and Y coordinate. So that is elimination. Yay. I do also want to talk about one more thing while we're here. So if we go back to the very beginning, we talked about, we talked about subtracting here. You could also think about this as multiplying by -1 and distributing that, and then adding those two equations, if you prefer that. They are the same thing, just looks a little bit different, right? Okay, you guys, well, I hope that this helped you. If you need any more help, don't be afraid to reach out.